All right. So starting with the first one, prove that De Morgan's law A union B complement is equal to A complement intersect B complement. Now, first thing first, we are going to work with the left hand side. Okay, so on the left hand side, what do we have? We have got A union B complement. So what I'm going to do is I'm going to let this be equal to x be a member of this set. So say let x be a member of A union B complement. This means that since x is a member, look at this, since x is a member of A union B complement, okay, meaning that uh, X will not be a member of A union B. Okay, is that okay? All right. Like if it is a member of the complement, obviously it's not going to be a member of A union B. And then from here, what are we going to do? Since X is a member of A union B, okay, now we know union is supposed to, the word union, like we need to know union will be represented by the word O. Okay, and the word and means intersection. Now in such a case like this one, instead of following this, since we are saying not a member, so O doesn't represent union in this case. Okay, so O is going to represent intersection, meaning that X is a member, okay, is not a member, I mean, of A and, so let me put just U union X is not a member of B. Since X is not a member of A and X is not a member of B, meaning that X is a member of A complement. Now, instead of using what word was supposed to be, I'm sorry, I've not put a word. Supposed to use a word first before we get to proceed. Okay, so we are saying X is not a member of A, and we are now splitting this to and X is not a member of B. Remember I said the X being a member of A and the X being a member of B, union is supposed to mean what? O. So the word I was supposed to use here is O. But because we have got not a member, we are going to use and. So this means that X is a member of A complement because it wasn't a member of A. And then the word and now changes into what? Intersection. Okay? X is no is a member of B complement since it wasn't a member of B. This means that X is a member of A complement intersect B complement. So this is what we have. So what have we done? We have just shown that, remember this is the left hand side, this is the right hand side. So I've just shown that the left hand side is a subset of the right hand side. Why? Because the left hand side has given us the same value as the right hand side. Is that okay? Okay. After you show that, now we are going to go on the right hand side. So on the right hand side also I'm going to say let X, okay, let X be a member of A complement intersect B complement. What does this mean? It means that X uh, is a member of A complement and X is a member of B complement, right? This means that X is a member, is not a member of A, all right? or and X is not a member of B since they are members. Okay. After then, now this is going to change. You're going to bring them together. Now remember, and is supposed to mean intersection. But because this is not a member, to be X is not a member of A union B. All right. And then this becomes X is a member of A union B. Now you put a complement outside since it wasn't a member of A union B. Okay. So what we have just done here is we've shown that the right hand side is a subset of the left hand side. Now, when you have got the right hand side being a subset of the left hand side and the left hand side being a subset of the right hand side, that means that the left hand side is equal to the right hand side. Hence, proven. Are we good? So if you just use one side, then you've not shown because like it's concentrated on one side. So when showing, you're supposed to prove that both sides are going to be correct. Okay, so like the thing is this, you can have A being a subset of B, but B is not a subset of A. So in this case, these two are not equal. That is why you always need to show that A is a subset of B and then B is a subset of A. After then those two are equal. So that is how you get to take it. We are good? All right. Okay, so we go to the next one. Show that X is equal to X intersection Y union X intersection Y complement. All right, so I'm going to get the X intersection Y union X intersection Y complement. Now you're going to look at what is common in these two brackets. So again, you can see you have got X intersect, you also have X intersect. Okay, like the Y is not common. So I'm going to factorize out an X intersect. What will remain in this bracket is a Y. You get a sign on the middle union. What remain in this other one is a Y complement. So this will give us X intersect. Now Y union Y complement, like if you get what is outside the set plus everything within the set, that is going to give you the universal set. Okay, that will give you the universal set. So this means that Y union Y complement is the universal set. Now, if it was intersection here, Y intersection Y complement, like what is common between the inside of a set and outside of the set, that is not possible. So Y intersection Y complement is an empty set, but union is a universal set. Okay. Now every time you get a set, you intersect it with an universal set, it will just be that same set. Okay, so a set intersection and universal set is that same set. So this is going to give us X, hence shown. Are we okay? So Y intersection Y complement would be an empty set, like they don't intersect. You get that? All right. So part B. Express the following in the form a over b, where a and b are integers. Now we've been given 0.53333333. Now if you can see, so I'm going to say let x be equal to what you've been given. Now if you say 0.533, like the 3 is repeating, so I can also write this as 0.53, and on 3 I'll put a dash. Why? Because the 3 is repeating. So this is going to be equation 1. And then after then, the next thing that I'm going to do is the decimal point in front of the number that is repeating? No. Okay, so I need to take the decimal point in front of the number repeating. How do I do that? I need to multiply this equation by 10 so that the decimal point comes here. Okay, so multiply equation 1 by 10. So that will be x times 10, that is going to be 10x. And then 0.53 by 10, that will be 5.3 with a dash on top. This is going to be equation 2. After this, now, the next thing, make sure that the decimal point goes behind the repeat number. In this case, the number that is repeating uh, is only 3. So make sure that it goes behind. So how do you do that? Just multiply by 10. So again, say multiply. In this case, we're multiplying equation 2 by 10. So 10x times 10, that will be 100x. 5.3 times 10, that is going to be 53. The decimal point comes here, but since 3 is repeating, just write it once. Okay, this is going to be equation 3. The next thing, make sure that the equation where the decimal point is before the repeat number and the equation where the decimal point is behind the repeat number, they are subtracted. So in this case, it's equation 1 and equation 2. Okay, equation 1 and equation 2. So we're going to subtract those two not equation 1, but equation 2 and 3. Those are the ones where 1 is behind and 1 is in front of the repeat number. All right. So that is 100x being equal to 53.3. And then the other one is 10x being equal to 5.3. The 3, remember, is repeating. So we're subtracting this. Okay. So 100 minus 10, we know that is a 90. And then this 3 will cancel with this 3 at the end of the decimal point. So all you have is 53 minus 5. What do you get? Help me with that. 53 minus 5. 47. No, should be 48. Then divide both sides by 90. So that will be 48 over 90. Now there's a number that can go into both of these without leaving a remainder. So you need to divide by that number so that a remainder is not going to be left. Okay? Are we okay? All right. The next one. Given that square root of 5 is an irrational number, prove that square root of 5 plus 1 is an irrational number. So this is just basically telling us that when you add an irrational number with a rational number, what are you going to get? Is an irrational number. The first thing, make an assumption. So assume, okay, assume the number that you have is rational. That is square root of 5 plus 1 is rational. After making that assumption, it means that square root of 5 plus 1 can be written in the form a over b, okay, where a and b are integers in their simplest form, and then b, the denominator, cannot be equal to 0. After then, the next thing that you are going to do, take 1 the other side, so that will be square root of 5 is equal to 1, a over b minus 1. So this will give us square root of 5 being equal to a minus b over b. Now every time you subtract integers, the answer is always an integer. Okay? And every time you divide an integer over an integer, the answer will still be an integer. So this is telling us that on top, okay, on top, what we have is what? On top, like on top of this fraction. A minus b, a is an integer, b is an integer, meaning that you are going to have an integer because every time you subtract integers, the answer will always be what? An integer. And then on down also we have got a b, which is an integer. Now when you divide an integer over an integer, the answer is rational. Okay, the answer is rational. What does this mean? This means that the left hand side, you can see root 5, that is irrational. The right hand side, you can see we have got a rational number. And we clearly know that a rational number cannot be equal to an irrational number. So what have we done? That violates our assumption which we made at the beginning. So we're going to say, since the right hand side is rational but the left hand side is irrational, that violates our assumption, like they are not equal. That violates our assumption. Therefore, root 5 plus 1 is irrational. Is that okay? Yes. Can you just try to uplift your voice? Yes. Okay, you make sure that you make like one question like that. Okay? Just take like one question. You can send it to my inbox and then we're going to be able to go through it, okay? Okay, so let's go to the next one. Given that, determine whether the function f is even or odd. Now for this one, you can easily tell like power 3 is an odd number, power 1 is also an odd number. This means that this function is what? Odd. But to show f, you get the f, you put negative x where there is x, okay? You put negative x. So that means this will become f of negative x, and that is going to be equal to, I'm going to get negative x to the power 3, okay, plus negative x. So negative x to the power 3, we know that is just negative x power 3. And then positive times negative, that will be negative x. Right? So from here, we've seen that this function that we have gotten is not the same that with the function that we had, meaning that these functions are not what? This function is not even. Because for even, f of negative x should be equal to f of x. And then let's try to get to factorize. So what we have is f of negative x, that is going to be equal to negative. And then we're going to have x to the power 3 plus x if I factorize. So I've seen that what is inside here is the same as the function itself which we have, meaning that f of negative x is just the same as getting a negative multiplying with f of x. Meaning that the function here is what? The function is odd. Whenever you meet this statement, f of negative x is equal to negative f of x, meaning that the function is odd.